button. If you guys want the best view, make sure to pin my tab so you can see my work, okay? So make sure to pin my tab so y'all can see my work being done on the board. Juan Patino, since you are the most likely to respond, when I'm asking questions about can you see, will you be willing to respond by unmuting yourself and answering them?
Yeah, I got you.
All right, and it's just gonna be basic questions like can you see? That's it. All right, that's the main questions I want to ask. Gosh, I hope it's not. Does it come out mirrored? I hope not. All right, so I'm gonna write a word. I think I see it mirrored on my end, but we'll see. Can you guys read that as so in the correct direction or no? Juan?
Yeah, it's in the right direction. It's not mirrored for us.
Okay, cool. All right, so soka toa. Okay, soka toa. So just to kind of reiterate what this means, so stands for sine of the angle theta equals opposite over hypotenuse. S stands for sine, O stands for opposite, H stands for hypotenuse. Ka is cosine of theta equals adjacent over hypotenuse. Again, C stands for cosine, A stands for adjacent, and H stands for hypotenuse. And last, tangent of theta equals opposite over adjacent. T stands for tangent, O stands for opposite, and A stands for adjacent. Okay? So now we're gonna, let's see, problem 3. What's problem 3? Let me get a second Chromebook. Let me get a Chromebook so I can look at the problem. There you go. So I'm gonna do problem 3C. That's the most difficult one. So 3C, we have a triangle that looks like this. Okay. Wow. This is 4 square root of 31. 5 square root of 3. And 7. Okay. I know I didn't put an angle theta on this one, so I'm going to put the angle right here. That's going to be my angle theta. Okay. Any questions so far on that? No. Okay. So the instructions, I know they say find the 6 trigonometric ratio, but really we're just going to find 3. There's going to be sine of theta. Actually, I forgot to start recording myself. Let me put the record button before I forget. Oh no, I am recording. Okay. So we have sine of theta, we have cosine of theta, we have tangent of theta. Those are the 3 trig ratios. We're not going to worry about the other 3. There is no other 3. Sine of theta. Well, in order to solve for these, we need to label our sides opposite, adjacent, and hypotenuse. So sine of theta is opposite over hypotenuse, so 7 over 4 square root of 31. Okay? So normally we would be done with this problem at this point, but the problem does ask us to rationalize, meaning we don't want any radicals at the bottom. So what I'm going to do is I'm going to multiply top and bottom by the square root of 31 like this. All right? 7 times the square root of 31, they combine to just be 7 square root of 31. Since this one doesn't have a square root and this one does, you can't combine them. 4, right, stays on the outside. And an interesting thing happens here. When you multiply square root of 31 times the square root of 31, you just get a normal 31, like that. 4 times 31. Okay? So my answer for sine is 7 square root of 31 over 4 times 31, 124. And there's sine, rationalized. All right, so in the chat, Give me a 1 through 5. 1 didn't get it, 5 got it. How do we feel about solving for and rationalizing the problem? Solving for and rationalizing the problem. All right. So let's do cosine. Let's do cosine if we're kind of a little bit on edge about it. Let's do cosine in a bit. You guys want time to copy this down? Yes, no? All right, let me give you time to copy it down. Let me give you about a minute or two, okay? I'll step away so that way I don't write by accident. Remember, I can't see your questions right now, so I'm just stepping away to give you time to copy. I'll come back and look at the questions themselves. All right, so the next one is cosine of theta. Adjacent over hypotenuse. So adjacent, 5 square root of 3. Hypotenuse, 4 square root of 31. I don't care about the top, I care about the bottom. The bottom cannot have any square roots. So in order to cancel them out, I'm going to multiply top and bottom by the square root of 31 over the square root of 31. Okay? So 5 is outside the square root, so this is 5. And then inside the square root, we're going to have 3 times 31. On the bottom, we're going to have a 4 times, and since we have 2 of the same square roots, 31 and 31, we're going to have times 31. Like that. So my answer for cosine is 5 square root of 93 over 124. And there you go. That's how you find the cosine and rationalizers. So 1 through 5, 1 didn't get it, 5 got it. How do we understand the cosine example right there? Cool. All right, let me give you time to copy it down. I'll step away. All right, and then the last one is tangent opposite over adjacent. In this case, it is 7 over 5 square root of 3. There's a square root at the bottom. I want to cancel it out. 7 and square root of 3 stay separated. Bottom is 5 times 3. 7 square root of 3 over 15. And there we go. Those are the 3 trig ratios for this triangle. This is the hardest example of a triangle we have in this practice paper. So that's a good one to tackle right there. Okay. All right. So if I would also recommend take a screenshot at this point in case you lose your notes. You actually have the screenshot saved in your Chromebook. And not too panicked about, oh, wait a second, how did this happen? These are solutions also available online, but you might also want to take a screenshot. All right. Is there anybody in the chat who needs me to leave this up? Is there anybody in the chat who wants me to leave this up right now? Or do you
Yeah, just I'm copying it right now.
We're copying, okay, all right, so let me step away, let me give you a full, one more minute. Now, while you guys are copying this down, I would like some feedback. As far as, I know this is something new that I'm trying out, teaching with using the whiteboard like this, but how many of you find this a little bit better than me using the Chromebook or using the OneNote? Like, which one do you prefer? Me teaching up with the whiteboard right now, or me using the stylus and computer? Let me know in the chat, board or computer. Computer? Yeah, I just forgot my stylus today, so I do apologize about that. Both? Okay. Yeah. Yeah, if I still had my stylus, I'd be sitting down teaching from the computer, because that's what we're used to at this point. Well, at least I can help out with that. At least you guys are seeing a teacher teach up on a whiteboard, okay? So at least some of us can take pleasure in seeing actual old school teaching method. Although I wish it was a chalkboard. I wish it was a chalkboard. Weird, right? I want a chalkboard. Okay. Too much technology taking over. This is true. All right, so let me erase this at this point. Now let's go over problem number 4. Oh, I don't want to erase this though. This is fine information we have here. Why would I erase it? It's part of the whole freaking test. All right. So the next problem starts us off. This is 4B. This is 4B, okay? 4B, and it says that tangent of A equals 10/7. And you're supposed to draw a triangle, and this is a right triangle, so drawing a right triangle, this is A, this is B, and this is C. All right, A and B will always be the non-90-degree angles in these situations. Now, tangent of A, this is A, right? So this would be the opposite, this would be the hypotenuse, and this would be the adjacent. We know that tangent, based on SOHCAHTOA over here, tangent is opposite over adjacent, meaning, based on this fraction, 10 should be the opposite side, and 7 should be the adjacent side. So this is 10, and this is 7. All right, so this might have been a bit too much to intake all at once. So in the chat, yes or no, do you understand how I got those numbers there? Yes or no? Do you understand how I got those numbers there? All right, so I'm not seeing a no yet, but I'll let you guys copy down what I just talked about. And while you guys are copying, how about somebody in the chat tell me, how can I solve for the hypotenuse with this information? Can I solve for the hypotenuse? And what would I use? Ooh, nice, that was quick. Yes, I would use the Pythagorean theorem to help me solve for the hypotenuse. So let me give people about 30 seconds to a minute to finish copying down. Okay, so then A squared plus B squared equals C squared. C squared is only the hypotenuse. We don't know the hypotenuse in this case. This is 10 squared plus 7 squared equals C squared. 10 squared is 100. 7 squared is 49 equals c squared. This is 149 equals c squared. Take the square root of both sides, and I get that c equals the square root of 149. All right, you can plug in what that value in your calculator. Since this problem doesn't say rationalize, it doesn't really matter. But that's what I have right now. Okay. So this completes our triangle. Now this isn't this is part of the problem, is to have a complete triangle to work with. Okay. So the question that we're asked next is, okay, now that you have your triangle, what is sine of A? A is this corner. We already have stuff labeled based on A. Sine is opposite over hypotenuse. So this is 10 over the square root of 149. And if you really want to be as consistent in this test as possible, you can choose to rationalize this problem, even though it doesn't say rationalize. And you get 10 square root of 149 over 149. Okay? So yes or no in the chat. Yes, that makes sense. No, it doesn't make sense. How do you feel about that? This problem right here. Yes or no? Okay. Now, the second part of this problem is changing it up a bit. It says cosine, but in this case, not of A, but of B. So we don't care about this side anymore. This side is gone as far as our labels go. Those labels are gone. I should probably be using the eraser. Oh, well. And now we're focused in on B, and we're labeling based on B. So this is opposite, adjacent, and hypotenuse. So what we end up getting for cosine of B is actually 10 over the square root of 149, which is the same thing as 10 square root of 149 over 149. And there we go. That's the answer for cosine of B. All right. So in the chat, give me a 1 through 5. 1 didn't get it, 5 got it. How do we feel about this whole process of creating the triangle and finding sine, cosine, trigonodities of different angles? By the way, my computer is practicing social distancing. Is behind the plexiglass as I teach. Doesn't want to catch COVID, apparently. Cool. Well, we're getting it. All right, so I'll leave it up there for about a minute for people to copy down, have in your notes. Make sure to take a screenshot. This recording will go back up, by the way, so in case you feel like, oh man, he definitely went too fast, I didn't quite catch that. I'm gonna be putting up this recording. So don't necessarily panic about copying. And more just like kind of understanding the process and being able to see it later. Juan, do you need more time to copy that one?
I got it.
Got it? What about everyone else? Do we have it? All right, because I'm going to go over one more problem that the first period asked for, just to make sure that everybody's on the same page and gets the same video. All right, and that's problem 5A. Okay, we're gonna work, actually, I'm gonna do 5B. I'm gonna do 5B. 5B is it's a better representation of what you might see in the test. 5A is nice, but it's way too generous. It makes you use the same trig function twice. So I'm gonna do 5B now. By the way, I don't know if you all saw my videos, my original videos. There used to be 2 plushies here at the end, but I think COVID claimed them. Poor little plushies. 23, 75 degrees. X and 76 degrees. Okay, so the goal here is to solve for X. Okay, that is my goal. But if I look at this triangle on the left-hand side, I have an angle, that's it. It doesn't help me solve for X. I need to know at least one more side in order to solve for X. So I'm gonna go to the left triangle over here, which is also a right triangle. And I notice that both triangles share a side, this one in the middle. So I'm gonna call this side Y and actually solve for that side. If I can solve for that side, I'll have the minimum conditions necessary to solve for X on the right side. So I'm gonna start off by labeling the 75. Opposite, adjacent, and then the hypotenuse, okay? So chat, let me know, based on SOHCAHTOA, will I be using sine, cosine, or tangent to solve for Y? What would I be using, sine, cosine, or tangent? What would I use to solve for Y? Sine, cosine, or tangent? Let me know in the chat. Cool. See, I don't think I can trick you guys anymore with the sines, cosine, and tangent labeling, since you are all doing a pretty good job in kind of comprehending that. So good job. So yeah, setup wise, it starts off as sine of 75 degrees equals opposite Y or hypotenuse 23. So at this point, in your calculator, you would type in sine of 75, or you would, in Google, sine parentheses 75 degrees, closing parentheses. So I'm going to type it into a calculator I actually have. So on, see, whoops, there, sine 75. Oh man, it doesn't give me the answers in a, I don't want it like that. Let's see. Let's go scientific. Nope, that didn't help it. Mode. Sorry, I have to change the settings of this calculator because it wants to give me the degrees, the answer in radical form. I don't want it in radical form. Nope, that didn't help it. So sine of 75, there we go. I fixed my calculator. All right, 0.966 equals Y over 23. Put this over 1, cross multiply, and I get that Y is equal to 22.216. All right, I solved for Y. Up to that point, he made it 1 through 5. 1 didn't get it, or 5, I got it. How do we feel about at least solving the middle piece for this? How do we feel about solving for the middle piece? That's the first part you need to focus on. Solving this middle piece right here. The problem doesn't flat out tell you, hey, solve for the middle and then solve for the X, but you need to kind of make those decisions on your own. Okay. Let me give you about a minute to copy it down. All right, so now the goal is to solve for x. And we're gonna use new labels for that. We're gonna use new labels. So 26 degrees is here. This will be opposite. This will be adjacent, and this will be hypotenuse. If I want to solve for x, will I be using sine, cosine, or tangent to solve for x? Sine, cosine, or tangent? Let me know in the chat, sine, cosine, or tangent. Okay, I got one response. Sine, cosine, or tangent, what would I use to solve for x? Let me know in the chat. I'll wait a bit for that one. Because it means like people haven't caught up to this point yet, so it's better to wait. Nice, 2, 3, 4, okay. Let's get more responses going in the chat. Yeah, so the answer is tangent. So then in this case, tangent of 26 degrees equals opposite 22.216 over adjacent x. So I'm going to go into my calculator, type in tangent of 26, I get 0.488 equals 22.216 over x. Put one of the values over 1 and cross multiply. 0.488 x equals 22.216. Divide by 0.488. I get that x is equal to 45.525 if I round. And there we go. There's our answers. Okay? That's how I solved for x. So in the chat, give me 1 through 5. 1 didn't get it, 5 got it. How do we feel about the whole process now? Finding the middle piece and getting the other pieces. All right, so I'll give people about a minute to copy this problem down. I'm mirrored here, so it looks backwards to me, but you guys can see it fine, so that's good. That's good. All right. I'm gonna stop the recording pretty soon. Actually, I should stop the recording now. Away.